Hi everyone, my name is Thomas Kim. Today is February 22nd, 2020. This is my 30th episode about 3D graphics Intel TVB OpenCL Vulkan using Microsoft Visual C++. In this episode, I will cover Pro TVB page 227 using tasks to create your own algorithm. If you do not have Pro TVB, please double click this link and click download book PDF. In Pro TVB, page 277, chapter 10, using tasks to create your own algorithms. In next few sessions, I will discuss using task. But in this episode, I will demonstrate how to use task to implement our parallel algorithm. To understand my current session, you need to understand the placement operator new. Please double click this link. By watching this video, placement operator new, please make yourself familiar with the placement operator new. In our previous episode, please double click this link to download the source code from our previous episode. Show in folder, unzip it, rename 30 using task. Copy the folder, paste it to your working directory. This is my working directory. Start Visual Studio Code. Open the folder. In folder 30 using task, right click, rename task. Please double click it. This is the source code we created in our previous episode. From this file, copy this function up to this point. Copy, Ctrl and paste it here. Rename it, delete. We will delete this function after implementing our new algorithm. Copy this part, paste it here. Class Quicksort Task public TVB task. We have to inherit from TVB task class public iterator type begin end predicate type. This is the predicate type. We can put universal reference predicate. Public, we create constructor iterator type begin iterator type and predicate type predicate colon begin end predicate, or we can say just L value reference. Please note that this is universal reference, this is L value reference. Now copy this class name, paste, return type is pointer, execute. Please note that this is virtual function. Right click, go to definition. This class task defines virtual function execute. This is pure virtual function. It also has virtual destructor. So we don't need to worry about slicing problem because this base class defines virtual destructor. Now here auto begin, this begin, auto end, this end. Auto, I will put it reference predicate, this predicate. Now scroll up, we will copy this part, cut, paste it here. I will indent a little bit. We indented. Now I will introduce one more here. Size t cut off 8. It should be type name std vector int iterator. Now scroll down here, cut off, delete this part, and delete this part. Here, Quicksort Inplace std sequential. Here, begin, end, predicate. Now scroll up. We don't need this function now. We delete it. Here, we will modify like this. Also, we comment out like this. Now here, auto reference left sort. We dynamically allocate new this class. I pasted it here. Begin iterator predicate. It is placement new. This allocate child. It should be dereferenced. About this point, I explained in this video. So, you have to understand what is placement operator new. I will copy the link for your reference. Now, I will copy this part once again. Copy, paste. Now, this is right sort. And this should be iterator end. Now, this spawn. We spawn right sort first. This spawn. We spawn left sort. This wait for all. Now, we have to return null ptr. Scroll up. I will shrink this part. So this function should return pointer. In current session, I will return null ptr. But I made a mistake. Before we spawn this set reference count, we have to set reference count. 1 child, 2 child, so 2 plus 1. 2 is for children, 1 is for current task. Now we implemented a Quicksort class. Now template, size t, cut off, type name, container, type, std, vector int, type name, predicate type, std, less, talk play fun, remove constant reference t from this type. It has value type, type name. So it's a little bit complex. Then close it. Void Quicksort Task blocking. Container type. This is L value reference. CNTR. Predicate type. This is forwarding reference. Predicate. Here predicate type. Using container t talk play fun, I will introduce container type. Type name container t talk play fun, remove constant reference t, container type. I will copy this and paste it here. Then using iterator type, type name container t iterator. Using Quicksort Task t, we use this class. The first argument is cut off. The second argument is iterator type. Container t value type. Then the third argument is predicate. We will use reference. We will pass reference. So we defined Quicksort Task class. We defined this type here. Auto Quicksort Task. New Quicksort Task. This constructor takes two iterator. So cntr begin, this parameter cntr end. Then this predicate, this is reference. So predicate, it should be reference and the reference. Here tbb task allocate root. Okay. Now we define an instance of task tbb task spawn root and wait qst. Scroll up. I will copy this function, copy, paste it here. Test quicksort task blocking. Copy this function name, copy, paste it here. Disable it. Now we are calling this function here. Please note that this function takes container. So we have to fix like this. Now start command prompt. Please note that we are calling this function and this function calls this function. And this function use task dir cd 30 using task cl ehsc sdd c++17 task.cpp fe m.exe, hit enter. Wow, it built m. So this is our original unsorted vector, and this is sorted in ascending order, this is sorted in descending order. Now here we will increase 100. We build again cls. So this is 100 integers. This is sorted. This is sorted in descending order. Everything seems to be working properly. I understand this episode might be quite challenging. Please understand that I haven't tried to explain what is task and how to implement algorithms using task. Instead, I wanted to demonstrate how to use task. Beginning with the next episode, I will explain all the details one by one. So please be patient. In my next episode, I will explain simple Fibonacci sequence. Then I will explain how to implement parallel Fibonacci algorithm using parallel invoke. Then also in next episode, I will explain how to use task group. Then I will explain the lower level task interface. We will implement parallel Fibonacci algorithm using task. This task class is implemented in this code in figure 10.8. In my next episode, I will give you all the gory details about task programming. I will completely cover this book from chapter 1 to the last chapter, chapter 20. I will completely cover this book without skipping a single chapter or section. In case of chapter 5, chapter 6, chapter 7, chapter 8, chapter 9, I will cover chapter 10, chapter 11, chapter 12, chapter 13, chapter 14, chapter 15, up to chapter 16 first. Then I will go back to chapter 4, chapter 6, chapter 7, chapter 8, chapter 9. So please be patient. Please subscribe to my YouTube channel. Thank you for watching.